Welcome to Get Your FRQ On. This is from the 2016 exam, AB, question number 6, and it is not calculator active. In this question STEM, we are provided with different values of a function f, its derivative f prime, a second function g, and its derivative g prime. In the first part of the question, we are asked that if k of x is a function defined as f of g of x, write the tangent line to k at x equals 3. Right, so to find this equation of the tangent line to k of x at x equals 3, we have to find k prime of 3 to get the slope. We also have to find k of 3 to get the corresponding y coordinate. Right, by definition, k of 3 is just f of g of 3. Using the values of the table, this is f of 6. F of 6 turns out to be 4. So now we have our corresponding y coordinate. By the chain rule, k prime of 3 will be f prime at g of 3 times g prime of 3. All of those values, again, we can get from the table. So we have f prime of 6 times g prime of 3, which turns out to be 5 times 2, which is 10. So now we have the slope of our tangent line. All right, so from this we can conclude that the tangent line to k at x equals 3 would have the equation y minus 4 equals 10 times x minus 3. If h of x is g of x divided by f of x, find h prime of 1. Well, h prime of 1 can be found by using the quotient rule. So h prime of 1 would be f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 squared. And all of these values are available in the table, so we just look up in the table what they are, we substitute them in. F of 1 is negative 6, g prime of 1 is 8, g of 1 is 2, f prime of 1 is 3, and f of 1 squared would be negative 6 squared, which is 36. Simplifying all of this, we find that h prime of 1 is negative 3 over 2. In part C of this question, we are asked to evaluate the definite integral from 1 to 3 of f double prime of 2x dx. We don't really know anything about f double prime other than its antiderivative is f prime, which is in the table. To do this one, it might make sense to do a u substitution. You don't have to use a u substitution here, but I always like to use u substitutions because I find it really helps. If we let u equal 2x, then we find that du is equal to 2 dx, and therefore the dx part is just 1/2 of du. Okay? If I set up the definite integral using the u substitution, the integral from 1 to 3 of f double prime of 2x dx would be 1/2. The integral from 2 to 6 of f double prime of u du. But I have an antiderivative for f double prime, that's just f prime, and so applying the fundamental theorem of calculus, 1/2 times f prime of 6 minus f prime of 2. Those values I get from the table, and the definite integral has a value of 7/2. Now you may have noticed that in the original integral expression, the lower bound was 1 and the upper bound was 3. And after we did the u substitution, the lower bound was 2, the upper bound was 6. That is because when we do a u substitution, we have to substitute our bounds into our u function and then recalculate the bounds. So if the lower bound was 1, right, so now I put 1 in for x here, 2 times 1 is 2, my new lower bound is 2. So because I changed variables and did a u substitution, I also have to consider the fact that the bounds of my integral must be expressed in terms of u, not x. Right, likewise, 3 times 2 is 6, that's why the upper bound of my new integral in u is 6 and not 3. You don't have to use u substitution for this, and if you don't use a u substitution for this, you don't have to reevaluate the bounds. But if you do use a u substitution to calculate integrals on the AP exam, make certain that when you actually get to calculating the definite integral that you are using the correct bounds. If you're evaluating with respect to u, make sure your bounds are with respect to u as well. If you're only using a u substitution to come up with an antiderivative expression, you should change the bounds when you rewrite the definite integral and then change them back when you're done. But if you never change them at all and you end up evaluating the integral using the correct bounds basically as the result of making two mistakes, you should still get the correct answer, and I don't believe that you'll lose a point for that or fail to earn a point for doing that. This is really just a matter of writing a nice solution to the problem, making sure you're addressing all of the issues and the steps and so forth. But changing the bounds is something you ought to do if you do a u substitution. It's not something you're required to do, but still, get in the habit of writing good responses that communicate your intentions clearly.